Well, hello, geometers and seekers of truth. In this video, we will expand on our ideas from the previous work with triangles that are similar. So I've started a sentence here, and then we'll do an example and then finish the sentence together. If two polygons are similar with the lengths of corresponding sides in the ratio of A to B, then, and we typically want to say something about the areas. But before we get to the area, let's look at the situation we had before, all right? So let's suppose I had a length, I had some triangle or some picture here with a base and a height. Okay. And I'm just going to label these a couple of different variables. So let's say that this triangle here had a base, had a height of h and a base, and instead of using b, because that's going to confuse it with this ratio, we'll use something else. We'll use x. Okay. Then the area of this triangle is going to be 1/2 x, that's the base, times the height. Now let's compare that to a triangle that's similar to this. All right? And I don't mean similar like as just in colloquial terms, but in technical geometric terms, they are the same shape but different sizes. Okay. So we have this height here, and then we also have a base, except it's going to be a different value. This is going to be have a different ratio. So this is going to be h times a over b. Okay, because this is going to be our scale factor here. And then down here, instead of a value of x, it's going to be x times a over b. Okay. And you can see that this is going to get a little bit messy, but rest assured we can work through this and clean it up and get a pretty nice looking result. So the area of this triangle here that's been scaled up from the other triangle, the formula still applies the same way. It's going to be 1/2 the base of this. Okay, so the base of this is going to be x times a over b times the height, and the height here has been scaled up as well, so it's going to be h times a over b. Okay. And boy, I've got a lot of variables here, so we can combine some of the terms and just clean them up a little bit. I'm going to take, and this is all multiplication, so it's going to be 1/2 x h, and then I have an a over b, and then a second a over b. So when we combine that all together, it's going to end up being a squared, because it's a times a, over b squared. Okay. And when we look at the result here, what you see is that this is the area right here. This expression is the exact same thing as the area of the other triangle. So the areas of these two different triangles have a scale or a multiplier of a squared over b squared. Okay, so we can come up with our expression as follows. If two polygons are similar with lengths of corresponding sides in the ratio of a over b, then the ratio of the areas is going to be a squared over b squared. Okay. This is some things to emphasize here, is that the ratio of the areas that we're talking about here, not just the ratio of the side lengths. Okay. So I'm going to scroll back here so you just kind of see my example here from above. Going from this triangle to this triangle, we are doubling the base, right? So it increases by a factor of 2, and we're doubling the height. So we double the base, we double the height, and we end up quadrupling the area. So let me write this down again. We double the base of the triangle, we double the height of the triangle, so that leads us to a result of quadrupling, okay, or 2 squared. the area of the triangle when we're looking at similar triangles. Okay, so this is the big idea here for similar polygons in their areas. Whatever is the ratio of the side lengths, the ratio of the areas will be the side length ratios squared.